Hello everyone, this is lecture 142. These are some plane. This is an example of a plane on which the normal stresses P1 and P2 and shear stress Q is working at a perpendicular direction normal to each other. The plane which we have taken, that is BE at inclination of theta. So for the time being we put theta 1 and theta 2, but this is theta. So what will be the resultant stresses on the inclined plane with respect to major and minor axes? So we have got some formula, that is important formula. So that P, P is the measure working on the inclined plane and P dash is the minor. So this will be find out by these equations. What are the equations? This equation is P1 plus P2 by 2, that whatever the principal plane P1 and P2 normal stresses on the actual plane divided by 2 plus root over the difference of these two by 2 whole square plus q square. In the last lecture 41 we have used 2q, but this is q square, please take it q square, and P dash, which is the minor stress on the inclined plane, is given by P1 plus P2 by 2 minus this much, the same thing. So we can find out the normal stresses on the inclined plane, that is measure P and P dash by these two equations. And also we can find the angle tan to theta. Tan to theta is equal to 2q divided by P1 minus P2. This is your inclination. Already we can find out this 2 theta, tan 2 theta, 2q, P1 minus P2. So with the help of these three equations, we can always explore the values of P and P dash and the maximum shear which is developed along this in the plane. So this will be P minus P dash by 2. This is equation 4. The angle will be at angle theta 1 plus 45 or theta 1 plus 135 degree. So let us take an example and try to find out the solutions. If suppose in a plane A, B, C, D, normal stress is given, measure is 110, P2 minor is 47 and Q, which is 63 Newton per mm square. So how will explore, how will find out the normal, that is stresses on the inclined plane which is inclined at an angle of theta. Suppose this is your theta angle. For the time being we can take this is theta angle. So how to find out how to calculate these all things? So let us calculate the P by using this formula. So before calculating we can find out P1 plus P2 by 2, P1 minus P2 by 2. So we have calculated 110, 47 by 2, 78, and this 31.5, and Q is already given 63 Newton per mm square. So we can find out by using this formula that 78.5, this is coming 148.9 Newton per mm square, and P dash is coming 8.1 Newton per minute. Tan theta you can find out 2q upon P1 by, that is 2, and then theta equal to 63.26 or 243.26 degree. That will be theta. That will be theta. This is 2 theta. 2 theta is 10 over so this is 63.26 or 243. So by dividing half we can find out the value of theta. Theta is equals to 63.26 divided by 2 or 243.26 divided by 2. We can always find out. Now we can find out the maximum shear. That will be P minus P dash divided by 2. That is 148.9 minus 8.15. That is 70.4 Newton per mm square. So in this way we can find out the solution of inclined plane, normal and maximum shear stress which is working at angle of whatever be theta plus 45. Yeah, you can find out this theta is 63. Suppose 63.26. You divide it half. This will be your theta. So this will be your 2, 3, 31. This is 31 and this is 31, 63, 31.5. You can say 31.5 degree and 30 minute. This will be this one. So 5 degree is 40, that is 30. So this will be 31 degree, 43 minute. 0.5 means 30 minute. And 13 and 30, this will be 43. 31 plus 43. You can use 135. Another value that will be in this way, shearing in this way. This is your plane inclined to this theta, and this is inclined to this plane, that is theta 2. If this is inclined theta 1, if you take, then this will be at angle of 31 plus 45. 31, 43 minute plus 45. One will be like this and one will be, this will be 90, 890. You can use 6, 76, 43 minute. And another will be, you can add 90 degree more. So one part is in this and this 90 degree you can add. So this will be 6. So 166 degree 43 minute. This will be angle of this thing that we have added for the shear value. So in this way you can find out the solution of any problem which have the normal stresses on the plane and the angle is theta, inclined plane. On the inclined plane we can find out P and P dash, and with the help of these formulae we can find out the maximum shear which is developed, that is P minus P dash by 2, and the angle which is we can calculate, that will be theta 1 plus 45 degree or theta 1 plus 135 degree, which is given theta 1 45 degree or theta 1 135 degree. In this way we can find out the solution of this problem. So we'll take up some other problems with the help of Mohr circle in the next lecture. So thank you, attended class. Thank you very much. Thank you very much.